Human Geography, Chapter 8, Geographies of Economic Development. The garment industry in Bangladesh is a major supplier of mass market clothing for Western retailers like Gap, H&M, Old Navy, and Walmart. In the 1970s, the newly independent country had no modern industry at all. But by 2000, the garment industry was generating more than US $12.5 billion in export revenue. Today, Bangladesh earns $20 billion a year from garment exports. Women account for 80% of its 4 million employees, most of them working in terrible conditions for long hours and extremely low pay. A wide set of factors from financial innovation to government policy contributed to this dramatic change. In the country's economic geography, it began in 1979 when Daewoo Corporation of Korea teamed up with Bangladesh's Desh Garments Ltd. to produce garments in Bangladesh for export. Dash sent 130 newly recruited, technically qualified employees to Daewoo's garment factory in Korea, where they participated in an 8-month intensive training course covering topics from sewing skills to factory management, quality control, and international procurement and marketing skills that they then applied in the Desh factories in Bangladesh. Within a few years, almost all the trainees had left Desh to start their own garment businesses. Some of the ex-Desh workers joined new garment factories established by affluent businessmen, while others founded trading houses, which then contributed to the proliferation of garment manufacturers by providing a variety of valuable services, including international procurement and marketing, sample making, and design re-engineering. Observing Desh's good start in exporting and subsequently the success of ex-Desh workers, good start in exporting and subsequently the success of ex-Desh workers, highly educated people started their own garment business and wealthy families actively invested in the industry. Learning from one another, they clustered in a 20-kilometer corridor just north of Dhaka, the country's capital. Learning from abroad continued as some entrepreneurs participated in training programs in Singapore, Japan, and Europe. Other countries in East Asia followed Daewoo into operations in Bangladesh and invested in training Bangladeshi workers and managers. Thus, many Bangladeshi traders and manufacturers had work experience in garment trading and production, including the experience of working in joint ventures before starting their own businesses. Geographers are interested in understanding the principles behind such apparently serendipitous and complex processes of economic development, from international ties to the local concentrations of industry, from the circumstances of entrepreneurship and investment to the condition in local labor markets, and from the economic structure of countries and regions to the factors that influence the location of economic activities. Patterns of economic development. Sorry about that. We often discuss economic development in terms of levels of and rates of changes in prosperity as reflected in bottom line statistical measures of productivity, incomes, purchasing power, and consumption. Increased prosperity is only one aspect of economic development. However, for human geographers and other social scientists, the term economic development refers to the process of change involving the nature and composition of the economy of a particular region, as well as to increase the overall prosperity of a region. These processes can involve three types of changes. Changes in the structure of the region's economy. Example, a shift from agriculture to manufacturing. Changes in forms of economic organization within the region. For example, a shift from socialism to free market capitalism. Changes in the availability and use of technology within the region. Technological change and economic development. The Industrial Revolution, which began in England at the end of the 18th century, eventually resulted not only in the complete reorganization of the geography of the original European core of the world system, but also in an extension of the world system core to the United States and Japan. Since then, there have been several more technology systems, each opening new geographic frontiers and rewriting the geography of economic development while shifting the balance of advantages between regions. Overall, the opportunities for development created by each new technology system have been associated with the distinctive economic epochs and long-term fluctuations in the overall rate of change of prices in the economy. Beginning in the late 18th century, I'm trying to get the glare out. A series of technological innovations in power and energy transportation, and manufacturing processes resulted in crucial changes in patterns of economic development. Each of these major clusters of technological innovations created new demands for natural resources as well as new labor forces and markets. The result was that each major cluster of technological innovations, called technology systems, tended to favor different regions and different kinds of places. Technology systems are clustered of interrelated energy, transportation, and production technologies that dominate economic activity for several decades at a time, until a new cluster of improved technologies evolves. What is especially remarkable about technology systems is that so far they have come along at about 50-year intervals. Since the beginning of the Industrial Revolution, we can identify four of them. 1790 to 1840, early mechanization based on water power and steam engines, development of cotton textiles and ironworking, development of river transport systems, canals, and turnpike roads. 1840 to 1890, exploitation of coal-powered steam engines, steel products, railroads, world shipping, and machine tools. 1890 to 1950, exploitation of the internal combustion engine, oil and plastics, electrical and heavy engineering aircraft, radio and telecommunications. 1950 to 1990, exploitation of nuclear power, aerospace, electronics, and petrochemicals, development of limited access highways and global air routes. A fifth technology system, still incomplete, began to take shape in the 1980s with a series of innovations that are now being commercially exploited. 1990 onward, exploitation of solar energy, robotics, microelectronics, biotechnology, nanotechnology, advanced materials. For example,
I found this on the web.
Oh gosh, I'm sorry guys. I'm going to turn my phone off. Sorry about that. Fifth technology, still incomplete, began to take shape in the 1980s with a series of innovations that are now being commercially exploited. 1990 onward, exploitation of solar energy, robotics, microelectronics, biotechnology, nanotechnology, advanced materials, example fine chemicals and thermoplastics, and information technology. Example, the digital communications, telecommunications, and geographic information systems. Each of these technology systems has rewritten the geography of economic development as it has shifted the balance of advantages between regions. See Box 8.1. Visualizing geography. technological change and economic development. From the mid-1800s, industrial development spread to new regions. The growth of those regions then became interdependent with the fortunes of other regions through a complex web of production and trade. The unevenness of economic development. Geographically, the single most important feature of economic development is that it is uneven. At the global scale, this unevenness takes the form of core periphery contrasts within the evolving world system. See Chapter 2. These global core periphery contrasts are the results of a competitive economic system that is heavily influenced by cultural and political factors. Core regions within the world system, North America, Europe, and Japan, have the most diversified economies, the most advanced technologies, the highest levels of productivity, and the highest levels of prosperity. They are commonly referred to as developed regions. Processes of economic development are, of course, continuous, and no region can ever be regarded as fully developed. Other countries and regions, the periphery and semi-periphery of the world system, are often referred to as developing or less developed. Indeed, the nations of the periphery are often referred to as LDCs, less developed countries. Another popular term for the global periphery, developed as political label but now synonymous with economic development in popular usage, is the Third World. This term had its origin in the Cold War era of the 1950s and 1960s, when the newly independent countries of the periphery positioned themselves as a distinctive political bloc, aligned with neither the first world of developed capitalist countries nor the second world of the Soviet Union and its satellite countries. Measuring levels of economic development. At the global scale, levels of economic development are usually measured by economic indicators such as gross domestic product and gross national income. Gross domestic product, GDP, is an estimate of the total value of all materials, foodstuffs, goods, and services that are produced by a country in a particular year. To standardize for countries varying sizes, total GDP is normally divided by total population. That gives an indicator per capita GDP, which is a good yardstick of relative levels of economic development. Gross national income, the GNI, is a measure of the income that flows to a country from production wherever in the world that production occurs. For example, if a U.S.-owned company operating in another country sends some of its income profits back to the United States, this adds to the U.S. GNI. In making international comparisons, GDP and the GNI can be problematic because they are based in each nation's currency. As a result, it is now common to compare national currencies based on purchasing power. Parity, the PPP. In effect, PPP measures how much of a common market basket of goods and services each currency can purchase locally, including goods and services that are not traded internationally. When we use PPP-based currency values to compare levels of economic prosperity, we usually see lower GNI figures in wealthy countries because of the generally high cost of living and higher GNI figures in poor nations because of the generally lower cost of living. Nevertheless, even with this comparison between rich and poor, economic prosperity is very unevenly distributed across nations. As Figure 8.1 shows, most of the highest levels of economic development are to be found in northern latitudes, very roughly north of 30 degrees north, which has given rise to another popular shorthand of the world's economic geography. Quote, the north core, the core, and the south, the periphery. Valued in more detail, the global pattern of per capita GNI measured in the international dollars of PPP in 2012 is a direct reflection of the core semi-periphery structure of the world systems. In many of the core countries of North America, Northwestern Europe, and Japan, annual per capita GNI in PPP exceeds $30,000. The only other countries that match these levels are Australia and Singapore, where annual per capita GNI in 2012 was $43,000 and $60,110, respectively. I'll go ahead and show you this so you can take a look at 8.1. I'll try and get a back shot of that. Sorry. Semi-peripheral countries such as Brazil and Russia and Thailand have an annual per capita GNI ranging $10,000 and $25,000. In the rest of the world, the periphery annual capita GNI in PPP is typically less than $5,000. The gap between the highest per capita GNIs, more than $60,000 in Luxembourg, Norway, and Singapore, and the lowest, less than $600 in Burundi, Eritrea, Liberia, and the Democratic Republic of Congo is huge. The gap between the world's rich and poor is also getting wider. In 1970, the average GNI per capita of the 10 most prosperous countries in the world was 50 times greater than the average GNI capita of the 10 poorest countries. By 2012, the relative gap had increased to a factor of 70. Overall, more than 80% of the world's population lives in countries where income differentials are widening. Resources and development. Current patterns of economic development are the result of many different factors. One of the most important is the availability of key resources such as cultivatable land, energy, and valuable minerals. Unevenly distributed across the world are both key resources and, equally important, the combinations of energy and minerals crucial to economic development. A lack of natural resources can, of course, be remedied through international trade. Japan's success is a prime example for most countries. However, the resource base remains as important determinant of development. Energy. One particularly important resource in terms of the world's economic geography is energy. The major sources of commercial energy, oil, natural gas, and coal, are unevenly distributed across the globe. Most of the world's core economies are reasonably well off in terms of energy production, the major exception of being Japan. In parts of Europe, most peripheral countries, on the other hand, are energy poor. The major exceptions are Algeria, Ecuador, Gabon, Indonesia, Libya, Nigeria, Venezuela, and the Gulf states. All major producers, because of the unevenness energy, has come to be an important component of world trade. As more of the world becomes industrialized and developed, demand for oil continues to increase. Yet as we saw in Chapter 4, it is generally agreed that the peak of oil discovery was passed in the 1960s, and that the world started using more oil than was contained in new fields in 1981. Oil prices have risen sharply, more than 500% between 2000 and 2013. Oil is now the single most important commodity in world trade. making up more than 20% of the total by value in 2013. Newly discovered oil reserves in Canada and Brazil have eased short-term concerns about oil supplies, as has the introduction of hydraulic fracturing techniques, commonly known as fracking, to release hard to get at reserves of oil and natural gas. But both oil exploration and fracking are increasingly the focus of environmental concerns. For many peripheral countries, the cost of importing energy is a heavy burden. Consider, for example, the predicaments of countries like India, Ghana, Paraguay, Egypt, and Armenia, where in 2010 the cost of energy imports amounted to more than 1/4 of the total value of exported merchandise. Few peripheral countries can afford to consume energy on the scale of the developed economies. So patterns of commercial energy consumption mirror of the fundamental core periphery cleavage of the world economy. In 2008, energy consumption per capita in North America was 14 times that of India, 18 times that of Mozambique, and nearly 50 times that of Bangladesh. The world's high-income countries, with 15% of the world's population, use half its commercial energy and 10 times as much per capita as low-income countries. It should be noted that these figures do not reflect the use of firewood and other traditional fuels for cooking, lighting, heating, and sometimes industrial needs. In total, such forms probably account for around 20% of total world energy consumption. In parts of Africa and Asia, they account for up to 80% of energy consumption. This points to yet another core periphery contrast. Whereas massive investments in exploration and exploitation are enabling more of the developed energy consuming countries to become self-sufficient through various combinations of coal, oil, natural gas, hydroelectric power, and nuclear power. 1.5 billion people in the peripheral countries depend on collecting fuel wood as their principal source of energy. The collection of wood fuel causes considerable deforestation. The problem is most serious in densely populated locations, arid and semi-arid regions, and cooler mountainous areas, where the regeneration of shrubs, woodlands, and forests is particularly slow. Nearly 100 million people in 22 countries, 16 of them Africa, cannot meet their minimum energy needs, even by overcutting remaining forests. Cultivatable land. The distribution of cultivatable land is another important factor in international economic development. Much more than half of the Earth's land surface is unsuitable for any productive form of arable farming, as shown in figure 8.4. Poor soils, short growing seasons, arid climates, mountainous terrain, forest, and conservation limit the extent of agricultural land across much of the globe. As a result, the distribution of the world's cultivatable land is highly uneven, being concentrated in Europe, West Central Russia, Eastern North America, the Australian littoral, Latin America, India, Eastern China, and parts of the sub-Saharan Africa. Some of these regions may be marginal for arable farming because of marshy soils or other adverse conditions. Go ahead and show you pictures. While I'll come back to this. Irrigation or other factors sometimes extends to the local frontier of productive agriculture. We also have to bear in mind that not all cultivatable land is of the same quality. This leads to the concept of the carrying capacity of agricultural land, the maximum population that can be maintained in a place under current technologies is best practice without damaging the overall productivity of that or other places. Let me go ahead and go back so that you can see this. So you can get because they have a lot of information here. And then here is this section, visualizing geography. And what I'll do is I'll do it like this, and then I'll zoom in so that you can read it closer. Industrial resources. A high proportion of the world's key industrial resources, basic raw materials, are concentrated in Russia, the United States, Canada, South Africa, and Australia. The United States, for example, in addition to having 42% of the world's known resources of hydrocarbons, oil, natural gas, and oil shales, and 38% of lignite. I'm sorry. I think that's lignite, guys. Brown coal, unquote, used mainly in power stations, has 38% of molybdenum, used in metal alloys, 21% of the lead used for batteries, gasoline, and construction, 19% of the copper used for electrical wiring components and for coinage, 18% of the bituminous coal used for fuel in power stations and in the chemical industry, and 15% of the zinc. Russia has 68% of the vanadium used in metal alloys, 50% of the lignite, 38% of the bituminous coal, 35% of the manganese, 25% of the iron, and 19% of the hydrocarbons. Resources and developments. The concentration of known resources is in just few countries is largely a result of geology, but it is also partly function of countries' political and economic development. Political instability in much of post-colonial Africa, Asia, and Latin America has seriously hindered their exploration and exploitation of resources. In contrast, the relative affluence and great political stability of the United States have led to much more intensive exploration of resources. We should also bear in mind that the significance of particular resources is often tied to particular technologies. As technologies change, so do resource requirements, and the geography of economic development is, quote, rewritten. One important example of this was the switch in the manufacture of mass-produced textiles from natural fibers like wool and cotton to synthetic fibers. In the 1950s and 1960s, when this happened, many farmers in the U.S. South had to switch from cotton to other crops. Regions and countries that are heavily dependent on one particular resource are vulnerable to the consequences of technological change. They are also vulnerable to fluctuate fluctuations in the price set for their product on the world market. These vulnerabilities are particularly important for countries whose economies are dependent on non-fuel minerals, such as the Democratic Republic of Congo, copper, Mauritania, iron ore, Namibia, diamonds, Niger, uranium, Sierra Leone, diamonds, Togo, phosphates, and Zambia, copper. Resources and sustainability. The ideal of sustainable development is one that achieves a balance among economic growth, the environmental impacts of that growth, and the fairness or social equity of the distribution of the cost and benefits of that growth. The importance of this sustainability is cogently illustrated by the concept of an ecological footprint, which is a measure of human pressure on the natural environment from the consumption of renewable resources and the production of pollution. It represents a quantitative assessment of the biologically productive area required to produce the resources, food, energy, and materials, and to absorb the wastes of an individual, city, region, or country. The ecological footprint of a country or region changes in proportion to population size, average consumption per person, and the resource intensity of the technology being used. Humanity's footprint first grew larger than global biocapacity in the 1980s, and this overshoot has been increasing every year since in 2006 demand exceeded supply by about 40%. This means that it took almost a year and 5 months for Earth to produce the ecological resources we use in that year. At 9.0 hectares, 23.6 acres per person, the United States currently has the sixth largest per capita ecological footprint on the planet, just behind the United Arab Emirates, Qatar, Bahrain, Denmark, and Belgium. Other countries with extremely large ecological footprints include Australia, Canada, the Netherlands, Finland, and Sweden. Countries with the smallest ecological footprints between 0.5 and 0.75 hectares, 1.2 to 1.9 acres per person, include Afghanistan, Bangladesh, Haiti, and Malawi. Sustainable development means that using renewable natural resources in a manner that does not eliminate or degrade them by making greater use, for example, of solar and geothermal energy and recycled materials. It means managing economic systems so that all resources, physical and human, are used optimally. It means regulating economic systems so that the benefits of development are distributed more equitably, if only to prevent poverty from causing environmental degradation. It also means organizing societies so that improved education, healthcare, and social welfare can contribute to environmental awareness and sensitivity and on an improved quality of life. A final end and more radical aspect of sustainable development involves moving away from wholesale globalization toward increased localization, a return to more locally based economies where production, consumption, and decision making are oriented to local needs and conditions. Defined this way, sustainable development sounds eminently sensible yet impossibly utopian. A succession of international summit meetings on the topic has revealed deep conflicts of interest between core countries and peripheral countries. One of the most serious obstacles to prospects for sustainable development is continued heavy reliance on fossil fuels as the fundamental source of energy for economic development. This not only perpetuates international inequalities but also leads to transnational problems such as acid rain, global warming, climate change, deforestation, health hazards, and many would argue the sustainable alternative renewable energy generated from the sun, tides, waves, winds, rivers, and geothermal features has been pursued half heartedly because of the commercial interest of the powerful corporations and governments that control fossil fuels resources. A second important challenge to the possibility of sustainable development is the rate of demographic growth in peripheral countries. Sustainable development is feasible only if population size and growth are in harmony with the changing productive capacity of the ecosystem. It is estimated that 1.2 billion of the world's 6.9 billion people are undernourished and underweight. But the greatest single obstacle to sustainable development is the inadequacy of institutional framework. Sustainable development requires economic, financial, and fiscal decisions to be fully integrated with environmental and ecological decisions. National and local governments everywhere have evolved institutional structures that tend to separate decisions about what is economically rational and what is environmentally desirable. International organizations, while better placed to integrate policy across these sectors and better able to address economic and environmental spillovers from one country to another, have, with the notable exception of the European Union, not acquired sufficient power to promote integrated, harmonized policies without radical and widespread changes in value systems and unprecedented changes in political will. Sustainable development is likely to remain an embarrassing contradiction in terms. The economic structure of countries and regions. The economic structure of a country and region can be described in terms of its relative share of primary, secondary, tertiary, and quaternary economic activities. Variations in economic structure according to primary, secondary, tertiary, or quaternary activities reflect geographical. I'm going to go ahead and so you can see that. Geographical divisions of labor. Geographical divisions of labor are national, regional, and locally based economic specialization that have evolved into with the growth of the world systems of trade and politics and with the locational needs of successive technology systems. They represent one of the most important dimensions of economic development. For instance, countries whose economies are dominated by primary sector activities tend to have a relatively low per capita GDP. The exceptions are oil-rich countries such as Saudi Arabia, Qatar, and Venezuela, where the international division of labor, the specialization by countries to particular products for export, has produced national economies with a large scale or large secondary sector. Per capita GDP is much higher, as for example in Argentina and South Korea. The highest levels of per capita GDP, however, are associated with economies that are post-industrial economies where the tertiary and quaternary sectors have grown to dominate the workforce. With smaller but highly productive secondary sectors, as Figure 8.7 shows, the economic structure of much of the world is dominated by the primary sector in such of Africa and Asia. Between 50 and 75% of the labor force is engaged in primary sector activities such as agriculture, mining, fishing, and forestry. In contrast, the primary sector of the world's core regions is typically small, occupying only 5 to 10% of the labor force. The secondary sector is much larger in the core countries and in semi-peripheral countries, where the world's specialized manufacturing regions are located. In 2012, core countries accounted for almost three-quarters of world manufacturing value added. MVA. MVA is the net output of secondary industries. It is determined by adding up the value of all outputs and subtracting the value of all intermediate inputs. This share has been slowly decreasing. However, the core countries had an average annual growth rate for MVA at around 2% during 1990 through 2012, while the growth rate in the rest of the world was closer to 7%. This growth has been concentrated in semi-peripheral, newly industrializing countries in ICSs. The newly industrialization countries are countries formerly peripheral within the world system that have acquired a significant industrial sector, usually through foreign direct investment. Of the 20 biggest manufacturing countries in 2012, 7 were in ICSs: China, South Korea, Mexico, Brazil, India, Indonesia, and Thailand, listed here in order of importance. In terms of individual countries, the United States remains the most important source of manufactured goods and goods accounting for just over 22% of global MVA. In 2012, just 5 countries of the United States, Japan, Germany, China, and the United Kingdom together produced over 60% of the world total MVA. The highly capitalized manufacturing industries of the developed countries have been able to maintain high levels of worker productivity, with the result that the contribution of manufacturing to their GDP has remained relatively high, even as the size of their manufacturing labor force has decreased. Although the United States has retained its leadership as the world's major producer of manufactured goods, its dominance has been significantly reduced. China, in particular, has experienced a dramatic increase in manufacturing productions, achieving annual average growth rates during the 1970s, 1980s, 1990s, and 2000s of about 8%, 11%, 14%, and 9%, respectively. See box 8.2. Window on the world China's economic development. South Korea has also enjoyed a spectacular increase in manufacturing production, achieving annual average growth rates of almost 18% in the 1960s, 17% in the 1970s, 12% in the 1980s, more than 7% in the 1990s. 12% in the 1980s, 7% in the 1990s, and around 6% in the 2000s. More recently, other Pacific Rim NICSs, such as Malaysia and Thailand, have experienced rapid growth in manufacturing production. These shifts are part of a globalization of economic activity that has emerged as the overarching component of world's economic geography. As we shall see, It has been corporate strategy, particularly in strategies of large transnational corporations, TNCSs, which has created this globalization of economic safety. Transnational corporations are companies that particular participate not only in international trade but also in production, manufacturing, and or sales operations. In several countries, the tertiary and quaternary sectors are significant only in the most affluent countries of the core. Globalization has meant that knowledge based activities have become a critical aspect of economic development, resulting in the rapid growth for quaternary industries. Sorry about that. Knowledge and economics. For the world's core economies, knowledge has become more important than physical and human resources. In determining levels of economic well being, more than half of the GDP of major core countries is based on the production and distribution of knowledge in the United States. More workers are engaged in production and distribution knowledge than in marketing physical goods for the world's peripheral economies. Lack of knowledge, along with limited capacity to absorb and communicate knowledge, is an increasingly important barrier to economic development. Poor countries have fewer resources to devote research, development, and the acquisition of information technology. They also have fewer institutions for providing high quality education, fewer bodies that can enforce standards and performance, and only weakly developed organizations for gathering and disseminating that information needed for business transactions. As a result, economic productivity tends to fall relative to the performance of places and regions in core economies, where new technology is constantly generated and rapidly and effectively disseminated. All these problems are compounded by gender inequalities. See box 8.3. Spatial inequality, gender and economic development. This is the end of Chapter 8, Part 1.